Hey, 6th grade, how's it going? Today we continue learning about pie graphs, percentages, fractions, and quantities, understanding those types of data points in pie graphs. So let's continue on page 104. On page 104, we are looking at the same graph that's on the left. The one that we were looking at before has the toy cars and the stickers, right? And then the clothes and the books, which we looked at last time, right? We already found that the fraction for the number of books was half, right? And then the fractions for stickers and toys were both 1/8. So since we already know those two fractions, what we can do is we can plug in the numbers for his total savings, okay? If I take, for example, this is $5 right here, and this is $5 right there, and I know that this is twice that amount, okay, which is 10, and I know that 10 plus 5 plus 5 is 20, then his total savings must have been $40, right? All he did was take 5 plus 5 plus 10, and then I know that that amount, all of that amount, is the same as this amount of his books, which is 20 again, and 20 plus 20 is 40. All right, so let's check that to make sure that that's okay. Get rid of that. Here we go. Move that over. Yep, $40. Okay, it said what percentage of the savings did he spend on clothes? Well, it's a right angle, and all right angles are the same as 90 degrees, or 25%. So we can also take 1/4, which is the fraction, same as 25, right, times 100%, which then can be equal to 25%. Okay, we understand that right here, this 1/4 is the same thing as 25%, which is the same thing as 90 degrees. Okay, we need to be able to understand the degree amount equated to the amount of percent and the fraction. Okay, those are all equivalent. Let's take a look at the last problem, letter E. Find the ratio of the amount spent on toy cars to the amount spent on books. Well, since toy cars was $5 and books was $20, we can just take 5 over 20, and that, let me just write that on the screen. Let's see. All right, here we go. The amount spent on toy cars was $5, and the amount spent on books was $5, $10, $15, $20. Okay, here's my fraction, which I can also make into a ratio, 5 to 20. Okay, which can be simplified. If we divide both 5 and 20 by 5, we would get 1 to 4. That is your ratio, 1 to 4. Okay, let's go to the next problem. What I'm going to do is I'm going to show you a couple more problems that we did in class, right? Page 105. If we understand these types of problems, boys and girls, we can understand the whole idea of what the data really represents, right? So the problem on page 105 says there are 200 vehicles in a parking garage. Let me actually make this a little bit bigger so we can see this. Okay. The pie chart represents the number of each type of vehicle. So we have 40 motorcycles, 80 cars, 50 vans, 30 lorries, and we need to find out what each one of those is as a fraction. Now, this pie graph is actually made to scale, so we can actually separate this out pretty easily. If I wanted to separate this pie graph into sections, I would understand that this part right here actually represents 1/4, or, just like we found out before, 25%. Okay, but it only asks for the the fraction, right? So we already know that this is 1/4, and if 1/4 equals 50, then how much does 30 equal? How much does 40 equal? How much does 80 equal? Well, we can figure that out if we really wanted to. 1/4, what is the equivalent fraction for 50 over what? Well, we can multiply 50 times 4 and get 200. So the total would actually be 200. That's the total number, right? We already know that. So we can actually compare the number of lorries to the total, the number of motorcycles to the total, the number of cars to the total, and get our fractions. Let's do that actually on the next page. What I'm going to do is show you these quantities as fractions. All right. I know that the lorries is 40. So what I can do is take my lorry, which is 30, and put that over my total, which is 200. And then just simplify this fraction to get my regular finished fraction, right? I'm going to divide both sides by 10. That's 3 over 20, and that's the simplest that we're going to come, right? So 3/20ths is my final fraction for the number of lorries. Let's find out the motorcycles. Well, we know that there are 40 motorcycles, and there are 200 cars total. So if we take 40 over 200, we can simplify that to find our regular fraction. I'm going to divide both sides by 10, then I can actually divide both sides by 4. 4 divided by 4 equals 1, and 20 divided by 4 equals 5. So my fraction is 1/5 motorcycles. All right, we're left with cars. We already know that this is 1/4. I don't need to do that one again. Cars, we have 80 cars and 200 vehicles total. Sorry, that 2 doesn't look very good. Let me try that again. Divide both sides by 10. And 8 over 20, we can divide both sides by 4. So 8 divided by 4 equals 2. And 20 divided by 4 equals 5. So 2/5 is the number of cars. Now, what's interesting is all of these fractions have different denominators, and that's actually okay. That's okay. If we wanted to add them all up one more time, we would have to convert each one of those denominators to the same denominator. In this case, I think it would be actually 20ths, okay? So 1/5 would be 5, 10, 15, 4 20ths, and 2/5 would be 8 20ths, and 1/4 would be 5 20ths, okay? So we can add all those up, and eventually it would be 20 20ths would equal our whole number. Check your answers and make sure that they're okay. And let's go on to the next problem. Okay, so there you go. There's your answers. One more time. Let's go on to page 106. This one was a little bit more difficult for most students. It says that there are 400 adults that were asked how often they jog in a week. The pie chart shows the different results. So, question letter A says, what fraction of the adults jog 3 times a week? Well, here we have 3 times a week, which is 3/8. Okay, the problem actually tells us the answer. It's pretty simple. What about letter B? Well, letter B says, what fraction of the adults jog once a week? Well, this right here, like we've said before, is 25% or 1/4. Okay, you see that square right there? That's 90 degrees of the whole 360-degree circle. So that means it's just 1/4 of the circle. Same with this one. 5 times a week is 1/4. Okay, so there's your 2 answers for letter A and B. Let's go on to letter C. It says, what fraction of the adults jog daily? Well, daily doesn't have a fraction, but if we already know that this right here is 3/8, and we know that these two are 1/4, we can try to figure out the daily. Now, how do we do that? Well, we're going to need to convert these fractions into the same denominator, okay? Let me explain why. If we don't convert them in the same denominator, we cannot add or subtract the fractions to figure out the missing part. So let's actually skip to the next couple of problems so I can show you this in a little bit easier format. All right. If I look at this chart right here, we're going to change each one of these denominators to the same thing, right? They're all going to be 18ths so that I can add up each one of them together. So let's actually go back to this problem right here. If we know that 3/8 of the adults jog 3 times a week, 1/4 of the adults jog once a week, and 1/4 of the adults jog 5 times a week, we can figure out the daily by just converting the fractions, right? So what I'm going to do, let's show you this step by step. We know that 3/8 plus 1/4 plus 1/4 plus the daily amount is going to give us 1, which also can be converted to our improper fraction, okay? Now, what do we need to do to try to figure out this daily? Well, we need to convert this 1/4 into eighths, which is the same as 2/8. I'm going to multiply both sides by 2. Okay, and now this becomes 2/8. 2/8 and 1/4 are equivalent fractions. This is also 2/8. Okay, so if I add up 2/8 plus 2/8 plus 3/8, we're just going to add the numerators. 2 plus 2 is 4 plus 3 is 7. So we actually have 7/8 plus this number equals 1. Well, now that I know that my denominator is going to be eighths, I know that 1 is also equal to 8 over 8. We've studied that before in the past, even in 4th grade, you studied that. So what's left to get to 8/8? Well, we already have 7/8. 1/8 is the only fraction that's left. Okay, so this answer is 1/8 of the adults jog daily. All right, so how many adults jog 3 times a week? Well, that's 3/8, right? But we need to figure out the quantity. Now we know that there's 400 adults total. So if we know that 3/8 is the fraction that represents the quantity, and I know that the total equals 400, I can equate 3/8 to some number over 400. Okay? I can multiply that if I really want to. I can divide. Let's take 3 times 400, which equals 1200. Multiply those, 1200, and then divide by 8. I don't really want to do it in my head, so I'm going to try it on the calculator. Excuse me. Let's try that. Okay. Let's try 1200 divided by 8 equals 150. Okay, so 150 adults jog 3 times a week. All right, so far we have our answer for letter C, and letter D. Let's try to figure out letter E. It says, how many adults jog 5 times a week? Well, we know that 1/4 of the adults jog 5 times a week, and we know that there are 400 adults total. This one's a little bit easier to understand because to get to 400, we multiplied by 100. So 1 times 100 is just 100. So, ooh, that was a really bad 0. Let's try that one more time. I know that 100 adults jog 5 times a week. Okay, let's check our answers to make sure that they're okay. We had 1/8, 150, and 100. Let's just check that to make sure that we're all on the same page. So 1/8, 150, and 100. Okay, let's go to the next part. The next problem is on page 160. I'm sorry, 107, sorry. A group of 180 students was asked to choose the club that they would like to join. The pie chart represents their choices. Now, we have a pie chart where we have half of the students that are taking computer class, and then a portion that are taking sports, chess, and art. Now, we don't know for sure if this art is 1/4 or less than 1/4. We cannot assume because it's not drawn to scale. Okay, so let's read the first question. What fraction of the students choose computer club. Well, that one we can pretty much assume is 1/2, okay, because it is half of the graph, all right? Even though the directions really don't say, this is half of the graph, okay? That's just the information that we know, right? So let's just assume that's 1/2, okay? Now, how do we figure out the next question? What fraction of the students chose art club? I'm actually going to cover this up so you guys can't see how I'm doing this. Let's try to figure this out. Art, okay. If I know that 1/6 of the students like sports, 1/2 of the students like computer, and 1/9 of the students like chess, this whole thing is going to equal 1. That's a given. That's obvious, right? So if I add 1/6 plus 1/9 plus 1/2 plus art, I'm going to equal 1. Our whole, right? Nuestro entero. But how do we figure out this number? Especially since 1/6, 1/9, and 1/2 don't have the same denominator. Ooh, that's a predicament. What are we going to do? Well, we need to convert that denominator into the same number. Well, how do we do that? We need to think about the multiples of these numbers. If we count by sixes, for example, 6, 12, 18, 24, or 9, 9, 18, 27, 36, or 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, we can find a common multiple among all three of those numbers. And the common multiple is 18. Okay, so I can actually switch 1/6 to some number over 18. And 1/9 to some number over 18. Okay, so how do we do that? Well, I'm going to multiply 6 times 3 to get to, oh, I just switched the color. Let me try that again. Here we go. Okay, 6 times 3 equals 18. So 1 times 3 equals 3. So this number now, 1/6, is actually equal to 3/18. Let's do the next one. 1/9 is some number over 18. Well, multiply 9 by 2 and 1 by 2, and I'm going to get 2/18. So this is the same as 2/18. Look at that. We already have two numbers that have the same denominator. We can start adding them. Computer. Well, I know that the computer is 1/2. So how do I switch that to 18ths? 2 times what number equals 18 times 9? Okay, we're going that way. So 1 times 9 equals 9. So 9/18. Whoa, that was a really weird 9. Try that again. Okay, cool. So now, boys and girls, we have 3/18. Let me change the color. We have 3/18. It never changed. Oh, yay. Stop. Blue. It's not going to let me change the color. Oh my goodness. Change. There we go. Did it change? Yeah. We have 3/18, we have 2/18, we have 9/18, and we have some number of 18ths. We don't know the art yet. Okay? So if we take 3 plus 2 plus 9, what do we get? 5 plus 9 is 14. 14/18. So if we have 14/18 plus the amount of art, we're going to come up with 18 over 18, which is our total, our whole, because our circle is made of a whole, right? So 14 plus what number equals 18? Well, that's 4. So this number is 4/18, which can be simplified. We'll actually divide both sides by 2, and that equals 2/9. Okay, there's our fraction, 2/9. 2/9 of the students like art, which actually makes a lot of sense because if you look at chess and art, the amount of art is twice the size of chess. So that answer actually is feasible. It's reasonable. Okay. Boys and girls, hopefully you understood this concept. that's the end of our class for today. We will continue with this concept next time, and I appreciate your participation. Thanks for coming to class, and we will talk to you guys on Thursday.